Hello all, I'm Catherine Sanchna, a MR PhD scholar from IIT Madras. Um, I, I will be giving live sessions every Monday between 6 p.m. and 8 p.m. And these videos will also be available on YouTube. So you can refer to them, the link for which will be given by the NPTEL team, okay, on the NPTEL website. So let us begin with this session. So last week we stopped with okay, circular curve. And I did not solve three problems related to circular curve, saying that I had due to lack of time. Okay, so let us begin by starting. So let us begin with those three questions that we left last week, and then we will move ahead to designing of horizontal curves. Okay, in detail. So um, as we saw, so we have come to the design of horizontal curves, right? And what are the elements of horizontal curves that needs to be designed? One is the radius, okay. One is the super elevation, okay, extra widening, okay. So these three needs to be fixed, right? Now in the first part which we saw last week for circular curve, we saw how to set the circular curve. So what are the main elements on the field that needs to be identified to set the circular curve, okay. So after this we will be moving on to designing the horizontal curve. So first we will be seeing, so first we were seeing how to set the horizontal curve, not exactly the procedure of setting the horizontal curve, but the various dimensions related to setting the horizontal curve, right? So these definitions we saw last week, okay. So the first one is the length of the curve, which is deflection angle into r. So the deflection angle is the angle subtended by the curve, right? So it is the angle subtended by the curve. Tangent length, so this is the tangent length, okay. It is given by this formula. Offset E is the distance from the apex here, so from the deflection point to the center of the curve, okay. Versine is the distance from the long chord, so this we will call it as the long chord, the distance from the long chord to this point, to this highest point of the curve, okay. So that is versine. And C, which we saw just now, it is the long chord, right? Now we will solve problems regarding this, okay, related to this. So I told you first, regarding the curves I need to explain something called as azimuth and bearing, okay. So what is azimuth and what is bearing? So you need to, so when you do surveying, right, so when you do surveying you need to specify, so there are two major components of surveying. One is the length length of any section and the angle subtended by that section. Only then you can survey a particular area, right? So if you plan to do surveying, or if you plan to do surveying, the basic elements that you need, okay, is the conventional elements maybe is the chain, okay, and something to measure the angle of the uh, path over which you are surveying, right? So so the units, or how this angle is represented is by using azimuth, okay. So let us say you have to measure the angle of something. So you are standing here, okay, and you see a building here, and you've been asked to find out the angle subtended by your sight of vision, okay, with respect to the building, okay, and say this is the north, okay. So you always specify the angles with respect to the directions, right? So you need a base direction to specify the angles, right? And that will be the basic directions that you know, which is north, south, east and west, right? So in order to specify the angles, Okay, you need to know where your basic directions are. So where the geographic directions are, which is the north, south, east and west, right? So if you've been asked to find out the angle of your line of sight with respect to a building here, you can do it in two ways. You can specify the angles in two ways. Either you can say that um, either you can make measure an angle with respect to the north. Okay, so this you will call it as theta. You will say that theta is the angle subtended by my line of sight with respect to the north. Okay, say if you have to measure the angle subtended by your line of sight with respect to a building here, let us call this as building B, then you will find out the angle with respect to the north again. Okay, so there are two ways of mentioning the angle. As I said, one way is you always measure the angles with respect to the north direction, and that measurement is what is called as azimuth. Okay, now even if it is here also, you will measure it like this. Okay, so this is called as azimuth. There is one more way of mentioning the of denoting angles. Okay, so and that will be so one way is with respect to the north always. So this is azimuth. Another way is you always specify the angles with respect to the north and south direction. Okay, so this is north, south, east and west, right? And if your angle is somewhere here, what is this quadrant called as? It is the northeast quadrant, right? So you will mention this quadrant first, which is north and east, and you will find out the angle subtended by this line with respect to the north. Okay, so you will mention it as north theta east. Okay, which means it is in the northeast quadrant, and it subtends an angle of theta with respect to north direction. Okay, now let us say you have to measure the angle of this line. Okay, now what you have to do is you have to identify the quadrant. You know that it is south and east, right? Now you should not measure the angle from the north. Okay, with respect to the north, your area should be limited to only this quadrant. So you will measure the angle from the south. So all the angles should always be measured with respect to the north or south direction. And in addition to that, you should also mention the quadrant in which you've been asked to find out the angle, right? So this is my theta. So you will write this as south theta east. Okay, so let us see for one more example. Say if your line of sight is here, if your line is here and you have to measure the angle, you will first write the quadrants south and west, and then you will find out what is the angle subtended by this line with respect to the south direction theta, and you will write it as south theta west. Okay, so this way of denoting the angles is called as bearing. Okay, so when they give you questions related to azimuth and bearing, and when they give you angles with respect to azimuth and bearing, you should be able to make it out. Okay, so first we will move on to the first question. The first question is so the first question is if the azimuth in degrees of the tangent at the start of the curve is 190 degrees. So you saw that for all these measurements, the deflection angle is required. And how this deflection angle is measured? It is measured with respect to this point, right? With respect to the intersection of two tangents. So what they will give you is, they will give you the direction of these two tangents. Okay, so they will give you the angle subtended by one tangent and the angle subtended by the other tangent. Okay, and with respect to that, you should find out with respect to these two tangents, you will be able to find out the deflection angle. Okay, so this is how you will find out the deflection angle, and once the deflection angle is known, based on other parameters that have been mentioned in the question, you can find out these 5 values, okay, whatever has been asked. Okay, so the first question is, if the azimuth of the tangent of the start of the curve, so this is the tangent, so this is the start of the curve, so they've given the azimuth for this tangent. Okay, so the azimuth for this tangent at the start of the curve is 190 degrees. We know what azimuth is, right? So we will first draw north, south, east and west directions. Now where will 190 degrees come in this quadrant? See, this is very different from the Cartesian coordinate system that you know, right? Or Cartesian, or sorry, not Cartesian, the polar coordinate system that you know. You know that this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant according to max. And in that, 190 degrees will come somewhere here, because the angles will start from 0, 90, 180, 270 and 360. So this is how we do it in math, right? Now here the angles will be coming in this direction, in the opposite direction. Okay, in math it will go in this direction, whereas in surveying it will come in this direction. Okay, so if this is north, south, east and west, okay, where will your 190 degrees come? It will, so this is 0, 90, 180, so your 180, 190 will be somewhere here. So your first tangent is somewhere here. Okay, so your first tangent is somewhere here. Now where is the second tangent? And the end of the curve is 100 degrees, right? So you know that if the starting tangent is here, the ending tangent has to be somewhere in this side, not here, right? So you know that the ending tangent, first we will separately draw the ending tangent and then we will connect these two. Okay, so the ending tangent, which is this one, the second tangent, this line, okay, this subtends an angle of 100 degrees. So where will 100 degrees come? 100 degrees, if this is north, south, east and west, 100 degrees will come. So this is 0, 90, 100 degrees will come somewhere here, right? Now how will you connect these two tangents? So you know that you have angle with respect to the for the start of the tangent, right? One which is here, and so this is the starting and the end is here. Okay, so this is the end. Okay, now you have to connect these two. How will you connect these two? This measurement is made at the start and this measurement is made at the end. Okay, so the connecting point for these two is this point. So you have to bring this point here. Okay, so this will be connected by like this. Okay, so this point has to be brought here. Okay, so this is my 190 degrees, which is the start tangent, and this is my ending tangent, which is 100 degrees. Okay, so this is the connecting point. Okay, because measurements have been made at the starting and the end. Okay, now you know that this is my deflection angle, right? So how will you find out the deflection angle? So this angle is 190 degrees. Okay, and this angle is 100 degrees, right? Now if you subtract these two, you will get the deflection angle, which is 90 degrees. Okay, so how did you get this? Just by geometry. Okay, so first we will draw two lines. Okay, this has So this is at 100 degrees and this is at 190 degrees. You've been asked to find out this angle, right? So ah, so this angle is with respect to the north, right? It is 190 degrees, and with respect to the north again it is 100 degrees, right? Now if you subtract these two, you will get the difference between the two, okay, and that will give you the deflection angle. So this is how you will get the deflection angle. Now based on this deflection angle, they've asked you to find out the length of the circular curve, right? You know that the length of the circular curve is r times deflection angle in radians, okay? So this 90 degrees is in degrees, right? So you have to substitute this in radian. The radius they've given it as 400 meters, okay? So 400 into, so what is 90 degrees in radian? It is pi by 2, right? And that will give you 1.57 into 400, which is 628.3 meters. So this will be the length of my curve, okay? Now moving on to the second question. So this is also the same question, but here the angle has been given with as bearing and not azimuth, okay? So the bearing of the start of the tangent is southwest 20 degrees. So let us draw how this tangent, so let us first observe how this tangent will look like. So this is north, south, east and west. So I have to draw an angle at 20 degrees in the southwest quadrant, okay? So this is my starting tangent, right? And my ending tangent will be southeast, right? So this is north, south, east and west. So it will be somewhere here, 20 degrees, okay? Now these two have to be connected. So which is the joining point? It is this, because measurements have been made with respect to this point, right? So I have to connect these two here. So this will be my final directions. So this is my starting tangent, which is 20 degrees, and this is my ending tangent, which is 20 degrees, okay? So my curve will come somewhere like this, okay? So in order to find out the difference, so in order to find out the deflection angle, which is this, which comes here at this inflection point, you have to find out the azimuth with respect to the bearing, okay? Only then it will be easy for you, right? And how will you do that? So first you have to find out the azimuth for this. So what is the azimuth for this? So if it is, so it comes here, right? So you know that this is 0, 90, 180 and this is 20 degrees more than 180. So azimuth is measured with respect to north always, right? So it is 180 plus 20, which is 200 degrees. So this is my start tangent. Now my end tangent, you know that this is 0 and this is 90 and this is 180, right? This is 180. Now this line is 20 degrees less than this 180 degrees. So this will be 160. So the difference between these two will give me 40 degrees Celsius, okay? Sorry, 40 degrees, I'm really sorry. Right? So now, with respect to this, you have to find out, so the radius of the curve is given as 100 meters. and the offset, so they've asked you to find out the offset. So the offset is given by r cos delta by 2 minus r. So if you substitute this in this equation, substitute for 40 degrees in cos delta by 2, you can substitute as degrees, okay. Whereas for if you substitute delta without any cos or sine term or tan term, without any trigonometry measures, you have to find out, you have to substitute in terms of radians. Whereas if you use cos, any trigonometric measures, you can use either radians or degrees to compute the final value, okay. So you have to substitute this delta and r in the equation of offset, and the final answer will be 193 meters, okay, if you substitute and see. Now moving on to the third question. So the radius of the horizontal curve is 100 meters, radius equal to 100 meters, and the deflection angle between the tangents is 40 degrees. So they've directly given you the deflection angle as 40 degrees, right? The tangent length would be what? So the tangent length is nothing but t. Okay, so this is the tangent length, and the equation for tangent length is r tan delta by 2. So simply substitute for r tan 40 by 2, okay, and this will give you 36 meters, okay. So these are the problems that should have been solved in the last class. Now moving on to the next set of problems which correspond to, so I actually want to do it in a different way, different than how we did previously. So previously I used to explain for 1 hour what sir, in a concise way, what sir taught in the previous week, and then the last 1 hour we used to be solving problems, right? But in this session I'm going to try it in a different way. You can give your suggestions as well, or you can let me know your opinion as well. So we will be solving the problems, and as and when we solve the problems, if we get any derivations, or if it demands any more further explanation than what is required for solving the problem, that also will be explained by me as and when we solve each question, okay. So please let me know if I'm going too fast, okay. If I'm speaking very fast also, please let me know in the chat box if you are not comfortable with unmuting yourself and talking. Okay, so the first question is before we could move to the problems, let us first see in brief, okay, what sir taught in the last week. So before that we saw setting of the curve, the points required for setting of a circular curve, okay. Till last week that was the agenda. Now for this week, you know that, so this week is entirely about horizontal curves. So in order to know about horizontal curves, you should know that a horizontal curve is a smooth transition from one direction to another, that you know very well, and this transition is given by a curve, and if it is a simple curve, it will have a constant radius of r, okay. So this curve is nothing but the arc of a circle, okay. And when you move on to a circular curve from a straight section, you know that in the straight section you will be having something called as the camber to take care of the drainage, right? But when you move on to when you move from a straight section to a circular section, to a horizontal curve, you will be, this camber will become something called as the super elevation, okay. So it will be kind of lifted at one end, okay, maybe this end or this end, depending on the direction of the horizontal curve, because the vehicles will be pulled outside. So if you see, the vehicles will be pulled outside when you're trying to traverse along a curve, right? So in order to take care of that, they would have provided super elevation on the curve. So this is one element of a horizontal curve. One more element is, so when you travel on a straight section, if the width of the road is W, when you traverse on a curved section, the width is kind of increased. Okay, you will kind of increase the width of the road on a horizontal curve, which you will call it as extra widening. Okay, so it will be denoted as WE. So on a curve you should remember that you will provide something called as super elevation, okay, on a road, um, in the cross sectional direction, and also you will be providing an extra width on the extra width for the lanes. Okay, so yeah, so and also I told you that when the vehicle is trying to traverse on a circular curve, it kinds it tends to get pulled outwards due to centrifugal force P. Okay, but so when it tends to get pulled outwards, okay, so there will be some frictional force generated with respect to the surface, right? So let us see from this figure. This figure is without any super elevation, so it is a flat surface without any super elevation. And if you see this figure, if this vehicle is pulled outside using a force P, it kind of offers a resistance to it, which is taken care of by the friction between the wheel and the pavement. Okay, when you saw about the stopping side distance, when we studied the stopping side distance, we saw something called as a longitudinal friction, because when you are trying to apply a brake, you feel friction in the longitudinal direction because your motion is also in the longitudinal direction, right? So you will try to apply a brake, and the and the friction will help you with stopping. In this case, the vehicle is trying to move outwards, right? So the friction, the resisting force which is offered by this friction between the tire and the pavement is in the opposite direction, right? So that is what you will see here as F. Okay, so this is called as lateral friction, and the lateral friction, the value of lateral friction is generally taken as 0.15. Remember, if you recall, the value of longitudinal friction for stopping side distance varied somewhere between 0.35 and 0.4, but for lateral friction we will consider lateral friction as 0.15. Okay, so moving on to the first problem, right? Okay, so let B, H and F denote the track distance, height of center of gravity of vehicle above pavement surface, and coefficient of longitudinal friction respectively. Okay, so let us first understand these terms. So this is the vehicle. Imagine this is the vehicle on the horizontal curve. The curve is a flat surface without any super elevation or even camber for that matter. Okay, so in this, if you see, this is your vehicle, and this vehicle has a width of B. What is this track width? This track width is nothing but the center distance between the wheels. So this is your track width, which is taken as B. And if your vehicle has a CG which is acting about this point, okay, so this is the point where the CG of the center of gravity of the vehicle acts. Okay, so from this point to the bottom, so to the surface of the pavement, the height is taken as H. Okay, so this is what they've given: height of center of gravity of vehicle above pavement surface and coefficient of longitudinal friction. So coefficient of, okay, so this is not coefficient of longitudinal friction, this coefficient of lateral friction actually. So this friction is given as F. Okay, as I told you, it acts in the direction opposite to the direction of application of centrifugal force, okay, which acts on a vehicle which tries to traverse on a horizontal curve, right? So these elements have been given. Okay, now they've given you, they've asked you to do some match the following, and if you see, you can see two terms here. One is skidding and one is overturning. So why, so when your vehicle tries to traverse on a circular curve, it should not, so you have to be careful that it should not skid, and also it should not overturn. So why will this skidding occur? We saw that if the vehicle is pulled in the horizontal direction outwards, okay, so this is the centrifugal force. Okay, when it is pulled outwards, your friction is going to resist it. Friction between the tire and the pavement is going to resist this action. Okay, if both of these are equal, so if the force exerted by this P is equal to the force exerted by this friction, then the vehicle is going to not undergo any skidding. It is going to be traveling in its path. But if there's a imbalance between these forces, right? If this centrifugal force is more, then it is going to slide outwards, right? So this you will call it as skidding. Okay, so either the vehicle may undergo skidding when traveling on a horizontal curve, or it may undergo overturning. Okay, if the forces are not properly balanced. Okay, you should make sure that the forces are properly balanced when you design the elements of a horizontal curve. Now so one more thing which happens is overturning. So I told you that the vehicle is pulled outwards, okay, right, pulled in this direction when it tries to traverse on a horizontal curve. When it is pulled in this direction, you can imagine that it has a possibility of getting overturned like this, right? The vehicle may get overturned like this and fall off, right, and topple over. Okay, so these are the two cases, cases that can occur when the vehicle is trying to traverse on a horizontal curve. Now I told you if the forces are proper, so this happens when the forces are properly balanced, when the forces are not balanced. Okay, when the forces acting on this vehicle are not balanced. If the forces acting on the vehicles are balanced, then this can be avoided. Okay, so first we will see how the forces are acting and how the forces needs to be balanced. Okay, so we saw that. Okay, so we saw for skidding, for skidding, the force exerted by, just a second. Okay, skidding, the force exerted by this this centrifugal force should be balanced by the force exerted by this um, frictional force, right? So if you see, for a body to be in equilibrium, the forces have to be balanced. Okay, if you remember your structure courses on structures, okay, mechanics of materials, sorry, not mechanics of materials, um, I'm not sure, but where will we learn simply supported beam, cantilever beam? Okay, so in that course we find out the resisting forces based on balance laws, right? You balance the vertical forces, you balance the horizontal forces, you balance the overturning forces, right? So for any body to be in equilibrium, the forces have to be balanced. So the what are the basic forces, what are the what are the basic laws that you apply is sum of vertical forces is 0, sum of horizontal forces is 0, or sum of moment about a point is 0. So if these three are satisfied, then the vehicle will be in equilibrium, which means so in this case, if you see, the vehicle will not undergo skidding or it will not undergo overturning. So as we saw, skidding is occurred by this pulling of the vehicle, pulling out of vehicle, pulling the vehicle out by the centrifugal force. Okay, so this is a horizontal force, right? And this has to be balanced by the frictional force, which is exerted by the between the tire and the pavement. Okay, so this comes under the topic of summation of horizontal forces is 0. So what is the horizontal force? To the right, it is P. Okay, so this acts in one direction. So you know, okay, you should know that each direction should have a sign convention. So let us take right side is positive and left side is negative. So P is acting in right side, so P is positive, plus P minus, since F is acting in left direction, let us place a minus sign here. Okay, minus. So this is nothing but frictional coefficient. F is nothing but frictional coefficient. Now we have to find out frictional force. Okay, so this frictional force is nothing but, so if you have a body which has a weight G, and if you're trying to push a body, okay, this is placed on a pavement. Okay, initially your body won't move. Okay, that is because it offers a frictional force, right? And this frictional force is nothing, so that is because of the friction between the body and the surface. Okay, so this friction, if this friction coefficient is taken as F, then the friction force which is offered by this body is nothing but this vertical force into the friction coefficient. Okay, so this friction force is offered in the opposite direction. Okay, only then when you're trying to push the body won't move, because it offers a resisting force due to this friction, which is equal to W into F. So which is equal to the vertical force into the frictional coefficient. In the same way, this tire, okay, it has a vertical force of RW, RA, right? This is the reaction of the tire of the pavement on the tire. Okay, so this is the vertical force, and the horizontal force due to this vertical force will be RA into F, right? Similarly, there's one friction force here, there's one frictional force here. Okay, and this has a vertical force of RA, and this has a vertical force of RB, right? So both these have to be added. So one frictional force is RA into F, and the other frictional force is RB into F. So all of this will be equal to 0. We saw that summation of horizontal forces is 0, right? So P is acting on the right, plus P minus RA into F minus RB into F is 0. Now if you group all of them, okay, so F into RA plus RB. So what is RA and RB? Now comes the summation of vertical forces. Okay, so this, if you see this vehicle, if this is the tire, it is, the pavement offers a resting force RA and RB. The weight of the vehicle is W. Okay, so in such cases, in order to find out what is RA and RB, you can equate sum of vertical forces equal to 0. So you know that RA plus RB, because they are acting in the upward direction, is equal to weight which is acting in the downward direction. So forces acting in the upward direction is equal to the forces acting in the downward direction for equilibrium, right? So this RA and RB can be replaced by W, right? So if you do that, you will get P is equals to F into W, right? Now in this question, if you see, there's something called as impact factor. You do not have P or W or anything like that, but you have something called as F and F, right? So in this equation also we have F, but we do not know what the impact factor is. So if P is equals to F into W, you can write P by W is equals to F. Okay, so this is what is called as impact factor, and that is what is given in the question. Okay, now this impact factor, so this is the force that causes the skidding, right? And this is the force that resists the skidding. Okay, now if your vehicle for your vehicle to not undergo skidding, you know that the force which causes the skidding should be less than the force which resists the skidding, right? So whatever is resisting my motion should be more. Okay, so in that case, P by W, if it is less than F, then there will be no skidding. So this is the rule. Okay, for skidding not to occur. Okay, so the impact factor should be less than F. Now moving on to the next criteria, we saw that when the vehicle is trying to move on a circular curve, it is going to have it can be affected by two cases. One is skidding and one is overturning, right? So we saw how to avoid skidding. Now moving on to how to avoid overturning. Okay, now to avoid overturning, so in the previous problem we saw summation of horizontal force 0, summation of vertical force 0. So all these balance equations were used. Now to you know that for overturning some moment is required. Okay, moment is something but a rotating force, like a turning force, right? So in order to find out how to avoid overturning, so if your vehicle is this, if it is going to be overturned, it undergoes some kind of turning force, right? So in order to find out what should be done or how the forces should be balanced such that this overturning does not occur, you have to equate the uh, moments. Okay, so whatever causes the turning forces have to be, so the forces causing the turning moments have to be equal, okay, equalized, so that uh, so that you will know how to avoid overturning. Okay, so summation of moment is 0. Now if you see, let me take the figure again. Okay, so moment can be taken about any point. Okay, so in this case let us take moment about the this point. Okay, you know what moment is, right? Moment occurs, so moment is nothing but force into perpendicular distance, right? Perpendicular distance. Now about this point, you know what are the forces acting. Okay, so summation of moments which, so okay, so this force P, okay, has a distance of h with respect to this point. What will this force P do to this point? It will try to overturn this vehicle like this, okay, because it is acting in this direction, okay, and it is with respect to this point. Okay, now say if I am taking moment about moment with respect to this point somewhere here, then my my body will rotate like this, tend to rotate like this, okay, because I'm taking moment with respect to this point. I should also know the distance from the point where the force acts to the point where I want to find out the moment. Okay, let us say h1, to find out the moment that is exerted by this force P at this point. Okay, so the direction of moments will depend moment will depend on the direction where the force is applied, and also the point at which you're taking the moment. So I'm taking moment about this point. Okay, now what are the forces that act? So you see that there is a force P which has a distance of h, there's a force Ra which has a distance of b by 2, because I told you the center to center distance is b, and there's one more force Rb which has a distance of again b by 2, right? So now if I take one more example I would like to give. If I take moment about this point, you will not take Ra at all, because the moment the force directly passes through this point, right? So there is no distance, there is no offset between the point where the force acts and the point where the moment is taken. Only when there is a distance when there is a distance between the point of application of force and the point of moment, okay, point where I take moment, only then you will get the value of moment, because moment is nothing but force into perpendicular distance. If I take moment about this point, you can take moment about any point. Okay, so if I take moment about this point, then this force will become, so the moment due to Ra will become 0, because there is no perpendicular distance between the point of point where Ra acts and the point where I am taking moment. Okay, so these are just basics which I wanted to say. Okay, now now let us take moment about the central point. Okay, we saw there are three forces. P will try to rotate the vehicle in this direction. Rb, if you see, it will try to rotate the body in this direction, because Rb acts in this upward direction, and the point where I am taking moment is this, right? It should be about the point where I take the moment. Okay, now Ra, it will try to rotate the body in this direction. Okay, I hope you understand how I'm saying the direction. Okay, it is always with respect to the imagine this point as the center of circle. Okay, now how will P, so how will the moment try to, so how will the direction of moment B for the force P. So it has to rotate about this point. Okay, so it has to come like this. Okay, because the distance is provided here. Okay, I hope you understand. So now all the moments which are in similar direction should be collected together. Okay, so moment which is, so let us write the moments to equations of moments first. So moment due to this point, this force P will be P into perpendicular distance. Perpendicular distance is H. Moment due to RA is RA into perpendicular distance. So this is the perpendicular distance. RA is acting in upward direction. So perpendicular distance will be horizontal direction, is B by 2, and RB is also the same. RB is B by 2. Now the directions are different, right? So RA and P are being try to rotate the body in clockwise direction, whereas RB tries to rotate the body in anti-clockwise direction. So summation of moments in one direction, clockwise direction, should be equal to the summation of moments in the anti-clockwise direction. So I am collecting, so it will become like this, right? Because this is the clock, these are the clockwise moments and this is the anti-clockwise moment. Okay, now when your body is trying to overturn, okay, this wheel will lose contact. Okay, okay, if this wheel loses contact, it will get lifted, right? So it will lose contact with the surface. If it loses contact with the surface, then the entire weight of the vehicle will be applied on this one wheel B. Okay, so which means there is no reaction at wheel A, so RA is equals to 0. So this will become 0. Okay, and RB, if you see, so what will RB be? We saw that RB can be found out by equating the vertical forces, right? So summation of vertical forces is 0. So weight of the vehicle is acting in the downward direction and RB is acting in the upward direction. So RB is nothing but W. So you can substitute RB by W. Okay, so P into H is equals to W B by 2. We know that P by W is the impact factor which is what they want. So it is B by 2H. So in order to avoid overturning, this impact force should be a maximum of B by 2H. Okay. Now you know that P is the force which is causing the vehicle to overturn and B by 2H is the resisting force. Okay, this is what it resists the vehicle from overturning. So if this P by W is less than B by 2H, okay, then there will not be any overturning. If it is greater than B by 2H, then the force, the overturning force is goes greater than the resisting force, so it will undergo overturning. So this is the criteria for overturning. So this is overturning, and if it is greater than this, then overturning is 0. Okay. Now going back to the question, we saw what is the criteria for the vehicle not undergoing overturning and what is the criteria for vehicle undergoing overturning. Okay. So let us write the criteria again here. If the impact factor is less than friction and if impact factor is less than B by 2H, okay, so this will cause no skidding and this will cause no overturning. Okay, so for the first point, impact factor less than B by 2H says that there is no overturning. Impact factor less than F says that there is no skidding. So the answer is C. Okay, so for 1 it is C. Impact factor greater than B by 2H says that there is overturning, and impact factor less than F says that there is no skidding. So the answer is B. And impact factor less than B by 2H says there is no overturning, and impact factor greater than F says that there is skidding. Okay, so 3 corresponds to A. Okay, so the answer to this is D. Okay, I hope you understood. Okay, now moving on to the next question. A horizontal curve has been laid on a state highway in plain terrain. Its radius is 360 meters. Okay. So they've given R as 360 meters. The track or center to center distance of the vehicle, we saw that track distance is nothing but B. So it is 2.2 meters, and its center of gravity is at a height of 0.75 meters from the carriageway level. So this is the center of gravity and it is at a height of 0.75 meters. So H is equals to 0.75 meters. Okay. Take standard values of other attributes. Okay. So if the pavement has been raised on the curved section, then if the pavement has not been raised on the curved section, what does this mean? The pavement is flat, which means the super elevation which we saw is 0. I hope you understood what super elevation is. Instead of this flat surface, it will have kind of a raised surface like this, okay, to take care of skidding or overturning. Okay, so this is super elevation, so they have not provided this. It means that the section is flat. Then the maximum vehicle speed to prevent overturning would be what? Okay, we saw the criteria for overturning, right? So we saw this P by W should be less than F. Instead of taking less than F, since we have to find out a particular value, we will simply equate it. So P by W is equal to F. So in order to prevent overturning, this is not for overturning, this is for skidding. Okay, B by 2H. So this is for overturning, right? So yeah, so B by 2H, right? Now you have to find out what is the maximum vehicle speed that can be with which the vehicle can travel to avoid overturning. Okay, now how will you find out? There is no V in this equation. How will you find out the vehicle speed? You have to use only this equation, because this is the equation that talks about overturning in a flat section, as we saw for the previous problem. You should know that the centrifugal force, the equation for centrifugal force is just a second. Okay, so it is mb square by r, where r is the radius of the curve, m is the mass of the body, and v is the velocity of the vehicle. Okay, m is the mass of the vehicle, v is the velocity of the vehicle. Okay, so you can simply substitute it here. So m into v square by r. Okay, what is w? W is the weight of the vehicle, and we know that weight is nothing but mass into acceleration due to gravity. So you can substitute for weight also, since you don't know the weight. So since weight is not given directly in the question, you can substitute for weight as m into g, and this has to be equated to b by 2h. Okay, so if you cancel it, you know that v is nothing but r b by 2h square root. Okay, so this equation is a standard equation which has been derived, and which I did here as well. Okay, so you simply have to substitute for the values that is given in the question to find out what is the maximum speed with which the vehicle can travel to avoid overturning. Okay, so this, what is the radius of the section? It is 360 meters. So it is 360 meters. The track distance is 2.2 meters. Here you will have g also. G is acceleration due to gravity. You can take standard value as 9.81. Okay, we saw it in the they've given in the question that you can take standard values for other attributes, which is the acceleration due to gravity. 2 is there in the problem, is there in the equation, and h, which is the distance of the center of gravity with respect to the carriage level, it is 0.75 meters, right? So if you substitute for all this, you will get the answer as 259.09 kilometers per hour. I've already converted, so this you will get it in meters per second, okay, because g is in meter per second squared. After that you can convert it into kilometers per hour. Okay, now moving on to the third question. Okay, yeah, if the pavement has not been raised on the curved section, same problem again. So the pavement has not been raised, which means it is a flat section. Then the maximum vehicle speed to prevent skidding. Okay, in the previous problem we saw overturning, now to prevent skidding. To prevent skidding, what did we see the equation as? The equation is P by impact factor should be equal to the frictional force. Okay, right. So now you can again substitute for P and W. So what is P? mv square by r is P and W is m into g. So this will be equal to F. Cancelling mass, V is nothing but root of R G F, right? And R is nothing but 360 meters into G is 9.81 into F, which is nothing but just a second. I told you that yeah, the standard value is 0.15. So I just wanted to confirm if it is given somewhere in the question. It is not given, and since they have asked you to take standard values, you can take it as 0.15, and if you solve for this, you will get the value of velocity as 82 point, speed of the vehicle as 82.86 kilometers per hour. Okay, now moving on to the next question. Okay, now comes the interesting part where the super elevation is provided. Okay, in such case, so when super elevation is provided, only if it is provided to the required amount, your vehicle will not undergo skidding and overtaking, right? So in that case also you have to find out using the equations of balance equations. You have to solve for the no skidding and no overturning cases. Okay, so if maximum permissible super elevation is provided on the curved section, the maximum vehicle speed to prevent skidding would be what? So first, like that, like how we solved for the flat section, first let us derive equations for raised section. Okay, so this is your raised section. Okay, now in the raised section, if you see, the force will still be acting horizontally and vertically only. Okay, so this is weight of the vehicle, which is acting which is acting vertically down, and this is the centrifugal force, which is acting horizontally. Okay, which is acting horizontally. Now, in order to make this problem simpler, okay, you have to resolve for the forces. Only then you can apply the balance laws, because say I told you summation of horizontal force is 0, summation of vertical force is 0. It is not always that case. Okay, this is general. Okay, the thing is summation of forces in one direction should be equal to the summation of forces in the other direction. It can be in any direction. So if my force is in this direction, then this has to be made equal to the forces in the opposite direction. Okay, only then the body here, any body which is here, will be in equilibrium. Okay, it need not be necessarily forces in horizontal direction or forces in vertical direction. Okay, so in this case you see that the vehicle is perpendicular with perpendicular, or it is resting on a slanting surface. Okay, and this surface is tilted at an angle of theta. Now in order to make this problem simpler, okay, or in order to equate the forces easily, you have to resolve for the forces. Okay, only because you see that friction is acting in this direction, right? So if you have to equate for friction, then you have to find out corresponding forces which are acting exactly opposite to it. Okay. Now if there is a force P acting in horizontal direction, it can be resolved in the sine and cos components, okay, with respect to the base of the road. Okay, so I'm resolving it with respect to the base of the road. Okay, so if this is theta, if this angle is theta, you see that the angle between, okay, this is my vehicle, just a second. Okay, so this is my vehicle and this is at an angle of, this is the horizontal surface, this is at an angle of theta. So my vehicle, the weight is acting vertically down. In order, but okay, so these are the wheels of the vehicle. Okay, so these will be offering a resisting force in this direction. Okay, so in order to equate it easily, you are going to resolve the forces which are perpendicular to the surface of the road. So this is the surface of the road, it is not horizontal, so, and this is perpendicular to it. Okay, so you're resolving forces in this direction with respect to the surface. Okay, so if this is theta, this angle is also theta. Okay, so if this and if this W, the angle with which is subtended by this theta is nothing but the cos component, W cos theta, and if you resolve this force you will get, so you can resolve it into cos and sine components, right? So if this is W cos theta, this is going to be W sine theta, and it is perpendicular to this W cos theta. Okay, it will be, so it will subtend a right angle here. Okay, now come, so you have resolved this one force which you know, which is W. Okay, RA and RB will be acting in this W cos theta direction only, because it is a resisting force, so it will be acting exactly opposite to where the vehicle wheels are. So since the vehicle wheels exert a slanting kind of force, this will also offer a force which is exactly opposite to it, like the weight is balanced and also the direction is exactly opposite to it. So RA and RB will not be perpendicular to the horizontal, but it will be perpendicular to the direction of the wheels. Okay, sorry, it will be perpendicular to the direction of the surface. Okay, so this is the surface and it will be perpendicular to it. Okay, now you know that P is acting in the horizontal direction. Okay, so you have to resolve this also. Okay, and if you see, this angle is theta. So if you resolve it, this will be P cos theta, and this vertical will be again, this will be P sin theta. Okay, now you know the forces which are acting in the respective directions. Okay, now in order to, so you know that this is F is acting in this slanting direction with respect to the surface of the road. Okay, now in order to find out what can prevent skidding, for preventing skidding, you know that you will use the equation summation of horizontal forces 0. In this case, you simply have to imagine yourself, you simply have to tilt your head. Okay, so this will be your page now. Okay, this will be your page. Your page itself has tilted, so this is how you have to see the problem. Okay, if you're going to take it as horizontal force as it is. Okay, so for this page, imagine this is your page. For this page, this is the horizontal force, right? These are the horizontal forces. Okay, I'm trying to say it in a simple way. Okay, so so now what are the horizontal forces now? This F into, okay, so this is the frictional coefficient, and this has to be multiplied with RA and RB, right? Because this is the normal force which is acting with respect to the tire. This is the vertical force which is acting with respect to the tire. This has to be equal to the force which is acting in this direction, which is P into cos theta, right? Now how to find out RA and RB? RA and RB you can find out by equating the summation, by taking summation of vertical forces 0, right? Now what are the vertical forces? RA plus RB, because they are acting in the upward direction, so they act in upward direction, they have to be equal to the forces that are acting in the downward direction, right? So what are the forces that are acting in the downward direction? It is W cos theta plus P sin theta. Okay, so in this equation you simply have to substitute F into W cos theta plus P sin theta is equal to, I forgot one more force here. See, P cos theta is acting in this direction, it is also horizontal, and W sin theta is acting in the other direction, so that is also horizontal, so minus W sin theta, so that I left. Okay, so P cos theta minus W sin theta. Okay, right? Now you can separate it in terms of cos and sin. Sorry, you can separate it in terms of yeah, one second. You can separate in terms of, so as we separated uh, the impact factor P by W, here also you can take P by W. So P into F sin theta minus cos theta is equal to W into cos theta minus sin theta, right? So P by W is equals to cos theta minus sin theta, sorry, this is F cos theta. So F cos theta minus sin theta by F sin theta minus cos theta. Just a second, did I do a mistake? One second. Yeah, I think I did a mistake. One second. Yeah, so P into F sin theta minus cos theta is equal to minus W into sin theta plus F cos theta. Alright, so this will be P by W is equal to sin theta plus F cos theta divided by, so I am just inverting the signs here, so cos theta minus F sin theta. Okay, you know what P is, so P is mb square by R, and W is m into G. Okay, this will be equal to sin theta. I can divide everything by, so I'll divide everything by cos theta, so divide the numerator and denominator by cos theta. Okay, so this will give me tan theta plus F by 1 minus F tan theta. Okay, so this tan theta is nothing but, so this is theta. Okay, this tan theta, if this theta is very small, you can take tan theta is equal to theta, and this is denoted by E, which you will call it as super elevation. Okay, usually the super elevation is represented in percentage. Okay, sorry, it is given in percentage, but when you are substituting it in this direction, so it will be E plus F by 1 minus E into F. Okay, so when you substitute it in this direction, this equation, you have to substitute in terms of fractions. Okay, so this is the equation for, in order to prevent skidding. Correct? So V square by GR is equal to 1 minus F by, sorry, 1 uh, tan theta plus F by 1 minus F tan theta. Okay, in this equation what you can do is, this 1 minus F tan theta can be approximated as 1. Okay, because F is small, tan theta is small, so 1 minus tan theta you can approximate it as 1. So if you take V by G, V square by GR is equal to tan theta, you just replace tan theta as E, so E plus F. So this is the equation to prevent skidding. Now what is asked in the equation question, if the pavement has not been raised on the curved section, sorry, if the pavement has been raised, if maximum permissible super elevation is provided on the curved section, what will be the maximum vehicular speed to prevent skidding? Okay. So what are the values that you need? So you have to find out what is the maximum speed. You know the value of R, it is given in the question, right? 360 meters. Okay. You know the value of G, 9.81. Okay. So all questions 2 to 6 what we are solving will have the same parameters. So radius is the same. So F we have to assume it as 0.15. No, now they've asked, they've told you that for a maximum super elevation given, what should be the maximum speed? So the maximum value of super elevation as per IRC is 7%, which is 0.07. So this also has to be assumed by you. You should know this value. Okay, so it is 0.07, and when you substitute this in this equation, you will get V as 100.34 kilometers per hour. Okay, you will get it in meters per second. You have to convert it into kilometers per hour. Okay, so that's all. Now moving on to the next question. So if the maximum permissible super elevation is provided on the curved section, same question, the maximum vehicular speed to prevent overturning is what? Okay, same question, but here instead of skidding, they've asked you how to prevent overturning, right? Now same case. Okay, we have resolved the forces. Okay, the resolved forces are given here. There we equated summation of horizontal forces 0. For overturning, what will we do? We have to equate summation of moment is equal to 0. Summation of moment about which point? I am taking summation of moment about the center point. Okay. Now let us do the following. Okay. So what are the forces which are acting? So one force is P into cos theta. Does it have a perpendicular distance? Yes, it has a perpendicular distance and it is equal to h, right? It has a distance of h. So it causes a moment. Okay. So this moment will be in this direction. So P cos theta into h. Okay. What is the other force in this direction? The same direction. We have to take the same direction, right? So there is a resisting force RA, and that also has, so that has a perpendicular distance of B by 2, right? Force is acting in upward direction, so the perpendicular distance to it is B by 2. So plus RA into B by 2, right, is equal to you have a horizontal force here. Okay, it has a perpendicular distance of h, so it will generate a moment, and the moment will be generated in this direction, in the anti-clockwise direction. So I'm grouping it in after the equal to sign, right? So W sin theta into h, right? And this plus you have one more resisting force here, RB. So this will also generate a anti-clockwise moment. So and the perpendicular distance to it is B by 2, right? So B by 2 into RB. Now I told you, see, there are other forces also. So P sin theta is also a force, P cos theta is also a force, but you're not taking moment about those forces. Why are you not taking, even if you take moment about these forces, the perpendicular distance is 0, right? My point is here, my force is passing exactly through the point, then there is no perpendicular distance, right? There is no perpendicular distance like this. So in that case, these no moment will be generated by these forces. So you're not taking W cos theta or P sin theta, okay? Now we know that when the vehicle is overturning, like it will lose contact with this tire. So this RA will be equal to 0 and RB will be equal to, so what will RB be equal to? It will not be equal to W. Why? Because there the RB was acting like this and the weight was acting exactly opposite to this. So summation of vertical force is 0. So RB is equal to W. But in this case, RB is acting in which direction? It is acting in this direction. And what are the forces which are exactly opposite to it? It is W cos theta and P sin theta. So RB is nothing but RB is equal to W cos theta plus P sin theta. Okay. So let us substitute this here. So P into H into cos theta is equals to P sin theta plus W cos theta, which is RB, into B by 2, right, plus WH sin theta, H sin theta. Right, now I am going to group the forces, right? PH cos theta minus PB by 2 sin theta is equal to WH sin theta plus WB by 2 cos theta. Okay. So P into H cos theta minus B by 2 sin theta is equal to W into H sin theta plus B by 2 cos theta. Okay, so P by W, which is the impact factor, is equal to H sin theta plus B by 2 cos theta divided by H cos theta minus B by 2 sin theta. Here also you can divide it by cos theta. Okay. And if you do that, so you divide it by cos theta, replace replace the P is equals to mv square by r and W is equals to m into g. Then you will get V, the equation of, so if you substitute all this, you will get gr B by 2h plus tan theta, okay, divided by 1 minus B by 2h tan theta, the whole power 1 by 2, all within square root. Okay, so this is the equation. Now if you substitute for, so what and all is given? R is given as 360 meters, G is 9.81, B is 2.2, tan theta is nothing but E is equals to 0.07, right? H is 0.75. So if you substitute for all this, the value that you will get is 279.96 kilometers per hour. Okay. All these values are not reasonable, but still they are asking you what is the maximum speed. It is just a theoretical solution. Okay. Now if maximum so the answer to this is 279.96. so this is the equation for maximum speed in order to prevent overturning on a super elevated section. Okay. If maximum permissible super elevation is provided on the curved section, then the maximum vehicle speed is to ensure equal pressure on inner and outer wheels is what? Okay. So okay. So they're asking you what should be the uh, maximum speed in order to ensure equal pressure on inner and outer wheels. Okay, so for inner and outer wheels, okay, so this is my vehicle and this has inner and outer wheels. So for both of them to have equal pressure, the frictional coefficient should be 0. Okay, this is if the frictional coefficient, lateral friction is 0, coefficient of lateral friction is 0, then you will get equal pressure on both the inner and outer wheels. Okay, so if you get um, so if you substitute for f as 0, then the equation, okay, will become, just a second. Okay, this is the equation which we saw for skidding, right? Um, on a elevated section. Yeah, v square by gr is equals to e plus f. Okay, in this equation they are saying that f has to be 0, only then equal pressure can be maintained in the inner and outer wheels. So if you do that, then your v will be equal to GRE square root. This e can be written as tan theta also. So if you substitute for all this, g is 9.81, r is 360 degrees, 360 meters, and e is 0.07 because they have given maximum permissible super elevation 0.07. And if you do that, you will get a value of 56.6 kilometers per hour. So this is the solution. Okay. If you have any questions, please stop me in between. Okay. A carriage bay has been constructed by raising the outer section on a circular curve at a rate of 5%. The vehicles will, okay, so this is your E. Okay, it has, by raising the outer section, they have given you how it is super elevated, the value, the percentage. So it is 0.05. The vehicles with track center to center distance B is 2 meters. Center of gravity, the height of center of gravity about carriage level, which is h, is 1 meter, and it is moving, the vehicle is moving at a speed of v is equals to 65 kilometers per hour. Okay, take the standard values of acceleration due to gravity. So you know g is 9.81 meters per second. Coefficient of lateral friction, f is 0.15. Yeah, standard values. The minimum radius of the curve to prevent overturning is what? Okay, so the equation for, yeah, so what is the equation for an elevated, super elevated section? We know that it is v square by gr is equals to e plus f, right? So you've been given all the other values, and you have to find out the radius of the section to prevent overturning, right? Sorry, the minimum radius to prevent overturning. So this is for skidding. We saw some other equation for overturning, right? Which is v is equals to gr b by 2h plus tan theta divided by 1 minus b by 2h tan theta. Yeah, we saw this, right? Now you have to substitute for all these values except for r, because you've been given all these values. Tan theta is 0.05, b is 2 meters, h is 1 meter, g is 9.81, r you have to find out, and v is 65 kilometers per hour. Okay, you have to make the necessary unit conversions. Okay, and the answer to this will be 30.06 meters. Now moving on to the next question. A circular curve is laid out on a major district road in mountainous terrain. Assume coefficient of lateral friction as 0.1 and take maximum values for the appropriate design speed and rate of superelevation. The absolute minimum radius if the area is not bounded by snow would be what? Okay, so in most of the cases we take only equations for skidding. Okay, so v square by gr is equals to e plus f is the equation that we always use to when we solve problems for horizontal curves, unless and until it is mentioned that check for check for overturning. Okay, so if they've specifically mentioned so what should be the velocity, what should be the speed, or what should be the radius to prevent overturning, only then you will use the equation for overturning. If not, you will use the equation for skidding. Okay, now what and all has been given and what has been asked. Okay, f is given as 0.1, g you have to assume it as 9.81, right? R is what you have to find out, and they've said that you have to find out the absolute minimum radius provided you give maximum values for design speed and rate of superelevation. Okay, now they've given so how will you know the speed of the vehicle? They gave you the type of terrain and also the type of road, so you have to pick the speed. So MDR, mountainous terrain. Okay, so the speed is 30 kilometers per hour, right? Why is it 30? Because they've asked you for absolute minimum radius. When they've asked you for absolute minimum radius, then you have to substitute for absolute minimum speed. Okay, so V is 30 kilometers per hour and the rate of superelevation, we saw that it is 7%. Okay, but that is for a normal section which is not bounded by snow. If the section that is for a general case. If they've specifically mentioned that it is not bounded by snow, then the maximum you can go to a maximum value of 10%. So E can be 0.1. Okay, so if they mention that it is not bounded by snow, then it is 10%. Okay, this is specifically for hilly areas. Okay, this 10% is for hilly areas and not bounded by snow. Okay, if it is bounded by snow, you have to take 7% only, and if it is a plain or rolling terrain, still you have to take 7% only. Since it is a hilly area and it is mentioned that it is not bounded by snow, then you have to take 10%. Okay, so E is equals to 0.1. So substituting for all this, you can get the value of R, and this will be 35.43 meters. Okay. Now moving on to the next question. A horizontal curve is laid on a 2-lane, 7-meter wide major district road in plain terrain. The radius of the curve is, so R is given, R is 250 meters, and the vehicles are moving at a speed of 80 kilometers per hour. Assume the length of wheelbase as 6 meters. Okay, L is 6 meters. We will see what L is later. Okay, first we will solve this problem. So this, I think this will come for problems 9 to 12. I'm not sure. Okay, so the horizontal, so the design value of the rate of superelevation is what? Okay, so this question corresponds to designing the superelevation. How will you provide? How will you? What value should be provided for superelevation? Okay, so there are a few steps as to how you should fix the superelevation of a road. The first step would be, so I told you, unless otherwise specified, the equation to find out to be used is v square by gr is equals to E plus F. Okay. Now first step would be, you have to assume that your super elevation will take care of 75% of the speed of the vehicles, and F will take care of 25% of the speed of the vehicles. Okay. So since they've asked you to find out super elevation, and since you know that F takes 25% of the speed and E takes 75% of the speed, you simply eliminate F. Okay, don't use F at all in this equation. So E takes care of 75% of speed, right? So instead of V as substituting for V as it is, you have to take V as 75% of V. So you have to substitute V as 0.75 V. So in this equation, first eliminate F, okay, and then use V as 0.75 V, okay. So use 0.75 V the whole square by G into R is equals to E, okay. You have to find out what is the value of E by using this criteria, okay. Now you will find out E, right. So if this E, you know that the maximum value of E is 7%. If this E is less than 7%, you can simply say that the super elevation percent that has to be provided for my road is something, say ED. So this, let us say this is ED, okay, design ED. If not, if it is greater than 7%, you cannot go beyond 7%, right. So what you have to do is fix E as 7%. So E as 7%. Now you have to bring in the effect of friction, okay. So what you have to do is include the entire equation, and this time you will not use 0.75 because you brought in the effect of friction as well. So use the equation again, V square by GR is equals to E plus F. Now you know the value of E. It is 7%, right? Because you fixed it as 7%. What this means is, my section, okay, cannot take care of only if the slope of the super elevated section is greater than 7%, okay, can it take care of this speed of vehicles, okay. But the maximum value that can be provided is 7%. So what it means is, I have to bring in the effect of friction as well. I have to ask the help of friction as well to make my section safe, okay. So in that case, I will fix E as 7% and find out what F is. How will I find out what F is? Because I know the radius, I know G, I know the velocity of the speed of the vehicles on the road. So using all these values, I can find the value of F. Now you know the maximum value of F is 0.15, right. Now the value that you find, say FD, is less than 0.15, you will provide, you can say that your section is safe. Just provide E as 7%, and the maximum friction, you cannot provide it, but you know that it is somewhere less than 0.15, which is good enough. If the value is greater than 0.15, you know that the maximum friction that can be generated by the surface is only 0.15, okay. So it cannot go beyond that. So you have to limit the friction value here to 0.15, because even if you take for value more than 0.15, the road cannot provide it, okay. It is the practical difficulty of the pavement, so it can provide only 0.15 friction. So if you assume that my road has a friction of 0.2%, and leave it as it is, the road actually cannot provide 0.2, right, a friction of 0.2. So what will happen is, vehicles tend to skid and leading to accidents. So in that case, you should know the practical difficulty that of your road, practical scenario of your road. It can provide only 0.15, so you have to provide 0.15. Now what will I do? I have fixed the maximum limit for super elevation as 7%. I fixed the maximum limit for friction as lateral friction as 0.15. How will I tell the so the road is not safe, because even after I have fixed the maximum values for all the possible elements, okay, still in order to satisfy this criteria, this skidding criteria, it is not enough, because only when the values are more will the skidding criteria be satisfied. So what I have to tell the users is, I cannot do anything about it. I have fixed the maximum elevation, maximum super elevation, the maximum friction has also been reached, so I will ask the users to reduce the speed of vehicles. Okay, that is the only thing that I can do. Either I can change the radius of the road, okay, because that also an important factor in this equation. But if the road has already been constructed, I cannot do anything about it, and all I can do is, oh no, if the alignment has already been fixed, okay, I cannot do anything about it. I can simply ask the vehicles to reduce their speed, okay, and I have to convey it to the drivers using a proper traffic signs, okay. So in that case, I have to reduce the speed. So the elements of the road will be E is equals to 7%, F is equals to 0.15, and with speed reduced. Okay, so this is the design. Okay, now the question that has been asked is about design. Okay, so what is the design value of rate of super elevation? So what is the first step that we saw? First step is regarding super elevation. What super elevation has to be provided? We saw that if in the first step, E takes care of 75% of the speed, so you simply have to substitute 0.75 instead of V instead of V, and in this equation, and equate it to E, right? So you, from here you can find out what is the value of E. So E is equals to 0.75 into, convert 80 into meters per second, okay, this the whole square, divided by G is 9.81 and R is 250. So the value that you will get for this is 0.11. So what is 0.11? 11%, right? So into 100, this is 11%. What is the maximum value of E? It is 7%. So ED, which is the design value, which I am finding out, is greater than 7%. So I have to move to step 2. Now step 1 is over. I have to move to step 2. What did I say about step 2? If the super elevation cannot exceeds the maximum value, then I have to ask the help of friction, right? So V square by G into R is equals to E plus F. Here I will not use 0.75 because because I've brought in the effect of friction, right? So here I will use E as 7% maximum, because since it exceeds 7%, I have to provide at least 7%. I cannot go beyond 7%, right? So substitute for V and find out F. Sorry, the question is 7. So the answer to this is 7%. So first we will answer this question, then we will move to the next question. So the design value of rate of super elevation, from the first step you saw that it is 11%, and I cannot provide 11%, I'm going to provide 7%. So the answer to this question is 7%. And what is the and this plain terrain MDR, we saw that for plain terrain the maximum is 7%. For hilly terrain, based on whether the road is snowbound or not, its value will differ, right? So maximum value will be 10% or 7% or whatever. So based on that only you have to say, not simply that super elevation maximum value is 7%. Based on the type of road, you have to identify what is the maximum super elevation that can be provided, and then use it in the problem. Okay. Now moving on to the next question. They've asked what is the coefficient of lateral friction. Now that you know that E is maximum of 7%, I have to ask the help of friction. So I'm using this equation, and in this equation I will substitute for V, right, by G into 250 is equals to E. I already know it is 7% plus F. So if I calculate F from this, I will get 0.131. Okay, is this value um, satisfactory. We saw that F has to be a maximum of 0.15. Okay, if the maximum friction that is offered by the surface is 0.15, and the friction that I get from this equation is only 0.131, which means I can stop the problem here. I can say that my design elements are maximum super elevation is 7%, friction is also within the required limit, so the vehicles can travel at the safe limit. Okay, so and so I can stop the problem here, right? If this value had been say 0.151 instead of 0.131, then what I would have done, I would have gone to the next step and I would have said, I would have fixed E as 7%, F as 0.15%, 0.15. So I will substitute E as 7%, F as 0.15, G I will substitute, R also I will substitute. I will find out the value of V, okay, corresponding to all these values. I know E, I know F, I know G, I know R. Okay, I will get a speed kind of less than 80. Okay, so the question in the question they have given the design speed is 80. Since um, the friction has also been exceeded, I told you that you have to reduce the speed of the vehicles in order for safe movement of vehicles on the curve, right? So in such case, you have to find out V by substituting for the maximum value of E and F and also the given values of G and R. Okay, and that speed, you have to say that the vehicles a speed limit has to be posted on the horizontal curve corresponding to the speed that you obtain using this method. Okay, so the equation, so the coefficient of lateral friction, we saw that it is 0.13. So what would be the restricted speed? Okay, so there in this problem there is no reason for you to provide restricted speed, right? But as we saw in the previous case, the speed will be restricted when E is maximum, maximum E has been reached and maximum friction has also been reached, right? So in such case, maximum friction is 1%. So I told you you have to find out restricted speed by substituting for the maximum values. So V square by G is 9.81 into 250 is the radius, E is 0.07 and F is 0.15. If you substitute for all these and find out speed, you will get a value. Okay, so that will be the restricted speed. Okay, now this is for 0.15 case. For my problem, my F is less than 0.15, right? So this in that case, you are not going to restrict the speed of the vehicles. So you can say that no restriction on speed. Okay, only when the speed when F has also reached a maximum limit, then you will go for reducing the speed of the vehicles, which you will do it by this method. Okay, so does anyone have any questions? I think we will see extra widening and this setting of super elevation, implementation of super elevation in the next session. Does anyone have any questions? Yes, Dinesh.
Hello, ma'am. Hello,
Yeah.
ma'am. From previous assignment,
Yeah.
question number 10 was related to DPR.
Question number 10 was related to
10 DPR. That
oh.
statement as given, and both the statement are corrected
Huh.
as you are explaining during the assignment solution.
Okay.
But I have given the answer as a both statement are correct, but I have given the marks as a zero for that particular question.
What assignment number is it?
Assignment number 6, ma'am. Last assignment.
Assignment 6, question 10, right?
Yes, madam.
Yeah, I will check and let you know.
Okay.
Okay. So if there are no more questions, then we can end the session.
समोरचा तुमच्याकडे पाहत असेल तेव्हा त्याला मागे पाठायला नको. माय आठवायला नको तर तुम्ही जगणार किंवा
So thank you all.
कारण आई नाही तर काही नाही देश नाही